Okay, in the last video we set up our equations or discussed, figured out what our equations were going to be. It's just the standard yaw rotation of a vector. However, there's still one more thing to change. We'll talk about that in just a moment. But it's not because of the math, it's because of how Panda3D is set up. But we'll see that in a moment. Involving our trig functions, which we need to do our trig functions, so we'll need to import the math library. So we can get our sine and cosine and everything we need for our math here. So now that we have our new yaw, pitch, and roll vector, I'm going to go ahead and grab that yaw row out of there. I'll call it target. Our target angle, if you want to label that specifically, might as well. Target angle is self.human.get h, which our yaw value, which in y was already used in positions, so they'd use a different letter for the yaw. And we're going to feed this into sine and cosine, which yaw is typically measured in degrees, and there's no exception here, so this returns an angle in degrees, but we need an angle in radians to feed into our trig functions. So we can just do math.pi divided by 180, a simple conversion. There is a math.radians method, but if you count characters, it's actually less to just do the conversion. Less characters to do the conversion than to type the name of the function for that. So I always just do the conversion. So that gives us our target angle, and now we can type in that formula we just figured out. And if you're not familiar with that, with linear algebra enough to have followed that, you can just copy this formula for 3D rotation of a 3D vector rotated about an angle. So our target angle is, we want to split that up into two components because we're only moving in the x and y, and we're rotating about the z, so the z is not changing. So we just have, not target angle, target x is what we just found. Math.cosine of our target angle, which we will need to offset, but we'll come back and offset in just a second because there's some more talking about that. Minus math.sine of our target angle, and we'll come back and offset it in just a second. Then our target y is going, and remember it's x times this minus y times this. So to keep this line a little simpler, I was just assuming a human vector, a unit vector. So one x times this minus y times this. But I'm going to go ahead and make the assumption that we have 1 for x and 1 for y to make this math easier. And then afterwards, we'll multiply it by our step size. We'll bring in a magnitude afterwards, just to make this line look a little bit easier. So our target y is then math.sine of our target angle plus y times math.cosine of our target angle. And now, if you think back to beginning trigonometry, you might remember that for sine and cosine, we actually want to be in the right half of our unit circle. So between negative pi halves and positive pi halves. So normally we would subtract pi halves just to move this from 0 to 180 to negative pi halves to positive pi halves. However, this standard yaw equation that I just copied down here is for counterclockwise rotation. That's the standard for measuring yaw. And Panda3D works with clockwise rotation. So essentially we have a negative angle here. So instead of subtracting pi halves, we actually want to add pi halves. But we want to split that up between both parts that make up our new component, so we need to split that in half again. math.pi divided by 4. There's more than one way to realize what the adjustment there is going to be. You can also, if it helps to think about the 1/2, the real 1/2, 1 over square root of 2, not that weird thing with whole numbers, the actual descriptive 1/2 of the real universe. We're splitting using that half, which is going to be the pi quarters value on both of them. Which in trig class you probably learned that is square root of 2 over 2. A weird way to write that too, but the actual 1/2, we need to split it up there. There's another way to get there, but I just think of the normal offset of pi halves, and our standards are counterclockwise. Panda3D is clockwise, which means our angle is negative. So instead of subtracting pi halves, we're going to add pi halves, but then we're splitting pi halves up between two parts of our new component. So same offset down here. Math.pi divided by 4 plus math.pi divided by 4. All right, so hopefully that wasn't too messy of math. That might be about the messiest math I have in this entire plan, even though I'm going to add some physics and stuff. That rotating a vector about an angle. If you've seen linear algebra, you're not going to think that's messy math. But if you have not seen linear algebra, that's going to look like the messiest math in everything I have planned here. And you can just copy that formula if you're not familiar with linear algebra. That's what we do to rotate an angle. And now that we have that angle, we can move in those components of that angle. So our new x is going to be the self.human.getX, where we were standing at, plus our step size times our target x. We could have just multiplied the step size in here, but I figured I'd do it here because that line's messy enough as it is. And our new y is the same thing. Self.human.getY, where we were standing at, plus our step size times our target y. And we haven't actually checked yet if we got the negative signs right on our linear speed. Those might need reversed. Or this one might need to be a minus sign. Either way, if it's backwards, one of those steps we'll just need to take the opposite of it. And that gives us a new x and a new y to feed into a new 3D vector, or this set fluid position is overloaded, so if we just feed in the components of a vector, it will create a 3D vector on the other side. So let's give this a run and see if that worked. So if I push forward, the W and D keys aren't working. Left and right are, but the W and S keys aren't doing anything. So let me track down that problem and I'll be right back. I must have missed something while I was talking. Okay, I tracked down the problem, and actually it turned out I forgot to hit save. So after typing all that, forgot to save it. So now that it is saved, we can come over and give it a test run. We push the W, well that should be forward and that's going backwards, so that is backwards. And that speed's a little high, so we could probably back that off. So I'm going to come over here, back that speed off. Let's try 0.1, and I'll make this negative. Wait, yeah. Well, actually, as I think about it, when we copy this over to an object, it's going to make more sense in my mind if we switch our negative signs here. So our forward actually gives us the negative linear speed, and our backward gives us the positive linear speed, and then we just add the step size times the component of that vector. So save that, because that's a very important thing before running the test. Turn left and right, forward and backward, and if we turn to the right, moves forward and backward that way. You can turn back and forth, left and right, over and over again, choose different angles, and our character just moves off in that angle we're facing. So there we have the rotation and step. That's what I always call it, the rotate and step movement versus the simple movement, which is just W and S move in the Y direction and A and D move in the X direction. So both types of movement, and both of them would work in 2 or 3D. Translating this into 2D would be a whole lot easier, because then we just, in 2D, we would, the 2D game, if we wanted to do the rotate and step, we would only need regular trig, where cosine gives us our X and sine gives us our Y. A little bit easier to do the math that way. That's why I wanted to explain it here, because it's can go over the complicated part. Hopefully all that math made sense, and if you have not seen linear algebra, then this is probably the most complicated equation that's going to show up in the whole tutorial. And if you have seen linear algebra, that's going to look like a simple equation. So if you're not familiar with it, just copy them. You'll just copy that. That's what it is every time. So that gets us through our loading characters in, and loading models, or loading our graphics in, and moving characters in both 2 and 3D. So now we're ready to start cleaning this up into the more usable form, more reusable form that we actually need, so that we can do it over and over and over again with a minimal amount of typing. So now we'll take this logic we just did and create a more formal version of the stuff loaded into games. Actually formalize it into some classes for both 2 and 3D games, instead of just loading it in directly. So we'll get started in that in the next video.